Hello everyone. In this video I am going to teach you the very important chapter of chemistry and especially of organic chemistry, which is the basic concepts of organic chemistry. You can call it GOC also, Journal Organic Chemistry. You can call it nomenclature, IUPAC. All these topics will be covered in this particular chapter. So first of all, as it is basics, let us start with the very first question, that what is organic chemistry? So organic chemistry, the definition has to be simple. So it is the chemistry in which we are going to study about organic compounds. Now the question comes that what is organic compounds? So here is the answer. Whichever compounds has the very great element, which is carbon in it, are called as organic compounds. Now there are two types of compounds, organic and inorganic. Now organic compounds are basically those compounds which are made from living beings or living organisms. Living organisms like plants and animals and us human beings. Whatever is produced from us comes under organic compounds. Okay, so now if I ask you what is the compound sugar, is it organic or inorganic? So now sugar is obtained from sugarcane. Sugarcane is a plant which is a living organism, so it lies under organic compound. So the study of sugar will come under organic chemistry. Now first of all, how do we represent these organic compounds? So that is why our very first topic is representation of organic chemistry. I hope the board is clear. Please bear my handwriting. I will improve it with time. So first of all, we will see the representation. Now there are many methods of representation of organic compounds. Let us study few of those. The first one, which we should know by now because we have studied this in the previous classes, that is structural formula. Structural formula. Okay, we also call this as Lewis structure. Lewis structure. It's actually Lewis formula, or the simple name as the dash structure or dash formula, whatever. It is very simple. Now don't get confused or frustrated by all these difficult names. This is the most simplest representation of organic molecules. Now let us take the very famous example of, guess what, CH4, that is methane. Now how do we represent this compound? Very simple. What we have to do is, first of all, we have to know how many elements are in this particular compound. two, right? One is carbon, second is hydrogen. Okay, now what are the symbols of carbon and hydrogen? So it is written here only, carbon C and hydrogen H. So then we have to represent their bond with a line or a dash. That is why it is called as a dash formula, dash structure. So this is represented as this. So this HH stands for the hydrogen, C stand in the middle stands for carbon, and the line or the dash represents the bond between them. Very simple. So here comes the second representation, which is called as the Lewis structure, or it is also called as the electron dot structure. Now, as per the name suggests, we can see that the bonds are represented by electron dots. So here is the very famous example, that is methane, and we can clearly see that the only difference between Lewis formula and Lewis structure is rather than the dash or the line, we are representing it by electron dots. So we should remember that each bond has 2 electrons in it, and similarly like the first representation, it also has elements represented by its symbol. Now this is called as the Lewis structure. And the third representation is the condensed formula. Now here I have taken another example, which is of the compound ethane. Now ethane means C2H6. Now how do we represent this in condensed formula? We have to do 2 steps. First is we have to recognize the identical groups. And secondly, we have to replace the some bonds by subscript. What does this mean? This means rather than writing C2H6, we will write CH3-CH3. So here I've again given a dash for representing their bonds between them. Now these two are the identical groups there, and the subscript is represented here. So this is how we write the condensed formula. It is also very simple. Now the main representation comes, which is the fourth one, which is the wedge formula. Now I couldn't draw anything better than this. I'm sorry for that. Now this is the wedge formula. In this we are using some different symbols, such as this. This is called as solid wedge. Solid wedge. Sorry for the background noise. Solid wedge. And this here is called as the dashed wedge. And this is just a dash or line, you can say. Now all these different symbols have different meaning. Now in this wedge formula, we are not representing the way we did in electron structure or in the dash formula. In this wedge formula, we are actually representing it in a 3-dimensional way. Because if you see the real molecules or the real compounds, we see that all of them are not in a single plane. Some might be behind the front carbon, some might be towards you. There has to be a three-dimensional shape. So that is why the wedge formula is very important, because it represents the compound in a three-dimensional way. So here, how do we have converted or visualized a three-dimensional molecule in a plain two-dimensional way.